Hello everyone. Today in linear programming, we have a problem of advertisement company. Here it says that a company ABC periodically sponsors public service seminars and programs. Currently, proportional plans are underway for this year program. Advertising alternatives include television, radio, and newspapers. So there are three alternatives. Audience estimates, cost, and maximize media usage limitation are as shown. So here we can say that as we have three alternatives, so our decision variable can be three. Like X1 will be number of advertisement in TV, X2 will be the advertisements in radio, and X3 will be the advertisements in newspaper. So later it says that the audience per advertisement are these, the cost per advertisement are these, and the maximum media usage. So we have these information to construct our objective function and as well as constraint. So, to ensure a balanced use of advertisement, radio advertisement must not exceed 50% of total number of advertisements. So, this one is a condition we will consider as constraint. And in addition, it says that television should account for at least 10% of the total number of advertisement. And if the proportional budget is limited to this, so the budget we have, which is limited to 1820, and the company would like to maximize the total audience contact. So the maximum audience, they need to maximize it. All right. So this is also a maximization problem, but for the audience. Okay. What is the allocation of the budget among the three media and what is the total audience reached? So here, let's construct an objective function first. So it will be 100,000 x1 plus 18,000 x2 plus 40,000 x3. Okay, now let's construct a constraint. Here, let's do the easy one first, which is if the proportional budget is limited to 18,200. So the proportional budget here, we have audience per advertisement and the cost per advertisement. So we will gonna be using this information, which will be of budgeting, and it says that it shouldn't be exceeding 18,200. It, so it's 18,200, and then the next one it says that advertisements must not exceed 50% of the total number of advertisements. So we are not sure of our total number of advertisement yet. So we can simply write as radio ads. The constraint would be x2 plus 50%. So 0.5 of the total advertisement. We can write it like this because we are not aware about the total advertisement yet. Or we can write something in proper formatting, which can be like 0.5 minus 0.5 x1 plus 0.5 x2 minus 0.5 x3. All right. So everything will be in the one side because in Excel and while we are solving in our studio as well, we usually write all the values on the right hand side and others in the left hand side. So it would be easier for us to, work like this. And here the third constraint, it can be television should account for at least 10% of a total number of attacks. So it says at least. So we can write TV ads. For TV ads, it can be X1. And for at least, we can write greater than and equals to 0.9 of the, sorry, 0.1 of the total number of advertisers. All right. Or we can write it like 0.9 x1 minus 0.1 x2 minus 0.1 x3 and simply greater than equals to 0. And the next one is the maximum media usage. So as it doesn't states the total number of maximum media here in this question, so we will be writing it separately for all the three alternatives. We can say for maximum usage, it can be for x1, it is greater than equals to 10. For x2, it is 20. And for x3, it is 10. All right. And at last, our non-negative constraint that our values shouldn't be less than or equals to 0. Okay, now let's solve this equation in Excel. I have attached the picture here so that we can easily note all the values. So first is our objective function, which is 100,000 for TV and 18,000 for our radio advertisement and 40,000 for newspaper. And for the budgeting, we have the constraint of 2,300 and then 600. And it should be within 18,200. For the radio ads, we have 0.5 x1, 0, 0.5 here, minus 0.5 here, sorry, and minus 0.5 here as well. It will be 0. And for TV ads, we have 0.9 minus 0.1 minus 0.1. All right, so here it goes 0 again. And for the maximum usage, we have all the 10, 20, and 10. All right. Okay, so for the left-hand side values, we have some product. So our first array would be this, and then it's 3 values. And we will gonna make it lock it. All right. So we can easily drag down and we can make sure that everything goes correctly. Okay. So yes, it is. And for here, our total number of audience, we can choose our objective function and then these 3 decision variables and it's done. Okay, now let's move on to our Access solver. Here, our objective function would be set to this, and it's a maximizing problem. So, yes, here we can write our decision variables to be these three. All right, and now we're subject to constraint. You need to add here, and then as these two are less than and equals to, so we can type this and then these like that. Add for this one, TV ads, it's greater than actually. So we will just change the sign and add this one. And again, for the last three, these are and equals to. So we will add this. Okay. Sorry. Yeah. Now, okay. For all that, and it's a simplex LP problem. No error, so it means we have done it right. So here we have our solution. The total number of audience for all three alternative goes here. And the total number of budget among all three medium are for TV it is 4, for radio it is 14, and for the newspaper it is 10. If we want to figure out the total amount of budget, we can like do it manually, like 2000 divided by 4, 300 divided by 14, 600 divided by 10. So it will be like total number of budget would be less than and equals to 18,200. And for this amount of budget, we have this much of our audience. Now in R, let us first check if our LP solve package is loaded. So well, it is. Now, while making our model, we have to consider our three variables, decision variables. So here I'm writing P for our three decision variables. And now let's make our objective function. Function which is set dot effective function model comma C, and then we have 10,000, 100,000, sorry, 18,000 and 40,000. All right. So here it is. Then our constant, which are add dot constant model C 2000, 300, 600 less than and equals to 18, 20. All right. Then now copy paste as we have six constraint. So we will copy six times. All right. And the next one is minus 0.5, 0.5, again minus 0.5. All right, and here it will be 0. All right, so the third one will be 0.9 minus 0.1 and minus 0.1. Here it will be greater than and equals to and 0. Okay, so the fourth one will be only x1 and the rest will be 0. All right, and it will be less than and equals to 10. Okay, here there will be only x2 value and it will be less than and equals to 20. All right, and then here at last there will be only x3 less than and equals to 10. Okay, and then it's up to you if you want to rename your rows and columns. Okay, now row N is C. First one is for budget. Second one is for radio ads. Third one was for TV ads. Fourth one was for maximum TV usage, maximum radio, and then maximum news. Okay. For columns, we have 3 decision variables, which were TV, radio, and newspaper. Okay then. Now dimensions for model list. Row N, comma, column N. Okay. Sorry, Taylor. Done. And then now the LP control function to control our model and indicate that it's for maximum. So maximum problem. Okay. Now print model, solve model. Here it comes 0. It means we are doing good so far. And now get our objective function for the model. Here it comes. Yeah, it's exactly same what we got in Excel. So now for our variables, get dot variable for our model, and it is just exactly similar what we have in Excel sheet. So it's up to you. We can paste a statement for that. That number of advertisement for TV is comma round off to get dot variables model And here's you. Query round. All right. And then now paste number of advertisement for radio. It's for the second one now. And again for the newspaper, we have done. And for the total number of audience, sorry, just copy and paste. Okay, so the total number of audience, total number of advertisement, sorry, is this. All right then. It's done for the R as well. Hope you understand. If you have any question, you can just write in a comment box. Thank you.